everyone, welcome to the first session on finite element analysis. Here I am going to discuss some introductory concepts about what is finite element analysis, what are the types of analysis that can be done, what are the advantages, disadvantages, and why do we still prefer using FEA, although there are certain disadvantages. Now I must mention that though I am starting with the lectures now, I have already recorded the answers portion of these lectures. So the numericals are already solved and they are uploaded in answers form. You can refer these numericals that I'm going to solve in the theory class, and you can also compare it with the solution of answers which I have already pre-shot and kept it ready on this channel. So let's start without further ado. What is FEA? FEA or FEM, as it is also known as, is a numerical method to solve some differential equations of mathematics. Engineering problems can be analyzed by the differential equations for the different processes. For example, there is a heat transfer through a wall taking place. So you can have a particular differential equation like d square theta by dx square minus m square theta is equal to 0. So this is a differential equation. Now this can be solved by using HT method, heat transfer. Also you can use FEA method for solving the numerical. So in these sessions I am going to specifically talk about them. Now for solving these, you can look here. I have mentioned that we are going to use certain suitable boundary conditions. Now when I say boundary conditions, you can just refer back to heat transfer through a wall. You will understand that at one end of the wall, you may have the temperature as 600 degrees Celsius and it is transmitting the heat to the environment. For example, let me say the environment temperature is 20 degrees Celsius. So in that case, the heat flow takes place from higher temperature to lower temperature. So I can apply two boundary conditions here. That is, temperature at one end is 600 and the temperature at the other end is 20 degrees Celsius. So this is known as boundary condition, which is at the two boundaries. However, problem arises when the differential equation becomes complex or the domain over which they are to be solved is complex. So in that case, you may not be able to use your heat transfer method, or you may not be able to solve directly by using mathematical differential equations. In that case, numerical method becomes very handy, and that is why the use of FEA or FEM. FEM stands for finite element method. Now I would like to just add a small thing before going to the next slide. That is, what is FEA? If you understand the term FEA, it is finite element analysis, which means you are doing analysis of a particular body when you divide it into finite number of elements, which means you're going to divide it into a mesh. If you have already gone through the videos of answers, you will completely understand what is mesh, what is meshing. Still, I'm going to discuss a little further. So that is the basic meaning of the term FEA or FEM. There are many applications of FEA. Technically, all fields are covered in FEA analysis. I'm going to only name a few here. The first one being structural analysis, wherein you can analyze civil structures like buildings, bridges, or say mechanical structures like machines or components of various parts. You can have vibrational analysis, which means there is a body which is subjected to some kind of vibration. A civil example could be a building which is subjected to earthquake, or a mechanical example could be a motor running and the table on which it is fixed, that is vibrating, or maybe a particular machine has a moving part or a motor which is working in it. So in that case, the body will be subjected to some amount of vibration. So vibrational analysis is also something which can be done in FEA. Next comes thermal analysis, very important, very much required in most of the applications because everything is subjected to change of temperature. So thermal analysis in that case becomes very important. There is steady state heat transfer, which is very important. For example, heat transfer subject, wherein you have studied heat transfer through fins or heat exchangers, or you can have furnaces, or you can have simple examples like refrigerator, wherein there is an insulating material. There are two other materials which are on the both sides of insulation, which is, like the refrigerator body or your ambience. So you can just calculate the heat transfer through various bodies. Next comes fluid analysis. Fluid is everywhere, so it is very much essential to do fluid analysis. For example, flow through pipes, or you can have effect of ambience on a particular building. It is called as fluid surface interaction. So fluid analysis is very important, and there are two types of options possible in FEA. They are called as modules actually. First one is ANSYS fluid and the other one is CFX. So these are some options which can be used. Next comes electrical circuit analysis, which means electrical analysis can also be done on FEA software. Non-linear analysis, all the analysis that we are going to do, most of the analysis is non-linear actually, but when we solve, we say it is linear, we assume it is linear and we calculate because the calculation becomes easier. But non-linear analysis can also be done in FEA. Apart from this, there are many other analysis which can be done. For example, nuclear engineering analysis can be done, or crash analysis is something which can be done, fatigue analysis can be done, buckling analysis can be done. There are n number of analysis which can be done on FEA. Everything around you can be analyzed on the software and also by using the numerical calculations. So this has very vast use, and definitely there'll be lots of advantages. First one is it helps in solving and analyzing problems with complex geometry, irregular shaped objects composed of different materials very easily. When you are doing analysis manually, or even it could be an analysis from the subject, when you use a theoretical method for calculation, if you have an irregular geometry or if you have complex geometry, it becomes very difficult. Also, when we analyze in particular subjects, we generally assume that the material is going to be homogeneous, isotropic. This is something which we assume, which means the value of E, K, and G, Young's modulus, bulk modulus, modulus of rigidity, and Poisson's ratio mu, we assume it is constant for every direction, which may not be so. So when you use a software or you use numerical analysis, it becomes much better and easier to solve. FEA generally greatly helps a design engineer in optimizing performance before actual fabrication, thereby reducing the cost of redesign to a great extent. Now, when I talk about this advantage, I'm basically talking about the software wherein you can design, you can analyze, and you can find out if my object is perfect for the required boundary conditions or the required conditions it is going to get subjected to. Once you realize that yes, it is in a proper working mode, you can go for manufacturing of it. If you watch few decades earlier, FEA came up around 20 to 30 years earlier. Before that, the process was to manufacture, test the material. If the material doesn't, pass the test, or if it is not able to give proper results, discard it, again manufacture and go for testing. So this used to be a repetitive process. Also, the amount of material that you waste and the manual labor is going to be very high. So this would increase the cost of the product. Now, if you observe with the recent times and with the use of these softwares, any product, for example, a chair on which you're sitting currently, can be modeled on FEA software. You can very simply analyze it and you can check if a person of a particular amount of weight sits on it, is the chair going to sustain? You can just make a rough calculation by using some theoretical methods and estimate what could be the value. You can design your chair, and when you model and analyze on the software, you will find whether the chair is going to be suitable or not, or what could be the maximum amount of load it can take. So this is just a simple example, most simple example which I can give it to you, but this can go up to a lot of examples, like the amount of load that an aeroplane body can take up. Also, you can calculate what could be the design of an aeroplane body when it is moving against a particular wind velocity. So these are higher level examples. So I'm just giving you an idea as to what difference in level you can obtain of results, when you're doing with an FEA software. Now, advanced softwares are now available to solve the problems of complex nature in minimum time, which means in very small amount of time with a good processor, with a good working machine, you can get the results very fast. Enhanced customer satisfaction can be ensured by using the finite element analysis. This is very much self-explanatory, and this is something which you also face these days when you have simple mobile bodies which are sleek, which are beautiful in design. You have beautiful covers, you have beautiful scratch guards over it, which helps you sustain, a lot of shock or sudden loading on it. So these are very, very simple examples, but very much important when it comes to customer satisfaction. But with every advantage, there is bound to be some disadvantages. So the first one is FEA is an approximate method. Hence, the results are not very accurate. You will find results which are precisely correct, but they are not exactly the same as that of methods by exact solutions. So this becomes a rough calculation which you get, a rough estimate. Though it is not very rough, I would say. I mean, it is not very wrong. It is very close to exact solution, but not exactly equal. The results greatly depend upon the experience and judgment of the designer. This is very true. When you obtain certain values on the software, you have to be quite experienced and your judgment has to be very sharp. Only then you would be able to decide if the values are correct and you can go forth in designing or manufacturing of your chairs, your aeroplane bodies, jet propeller, any object that you see around you. It is going to be based on the judgment of the person who is designing it. A powerful computer and reliable software is a must for FEA. This is something which is very important, and yes, it definitely requires a lot of investment. This increases the capital cost. Certain effects such as buckling, large deflections, material, and other types of non-linearities are not automatically included. This is just a disadvantage of the software, I would say. Maybe with time and with efforts, you will definitely find that these results are also getting added, and new modules will come up and you'll find better results. So, though there are disadvantages, there are definitely a lot of advantages. It's a lot of time saving, cost saving, effort saving. So, FEA on a software is something which is very useful and it is very much prevalent around the world. So, with this, I end the session. This was a very introductory lecture. From the next session onwards, I'll just start with some more basics which you need to know. So, see you in the next session. Thank you. দেখাচ্ছে তো watching. Hello everyone, welcome to the next session of finite element analysis. In the previous session, we have discussed about basic concepts of FEA and its prevalent use in the industries. After advancement in softwares like ANSYS, NISA, Nastran, MSc Adams, etc., these softwares are largely based on matrix algebra, and hence it is desirable that we discuss a little bit of matrices and their operations. So here you can see I have started with the representation of matrix. This is how a matrix is represented. A is say the matrix, M into N is the order of the matrix. Now I have taken an example here. A is 4 by 3. You can see there are 4 rows and there are 3 columns. So you can read here M value over here is 4, which indicates the number of rows, and N over here is 3, which indicates the number of columns. Each number in the matrix is called as an element. If you look at this matrix, each number in the matrix is called as an element. If you observe here, 1 is an element, 2 is an element. Likewise, all the numbers written over here are called as element. Example, Aij. Now this is something very different and important. I and J is again going to indicate the row number and the column number respectively for a particular element. So the small a is 1, suppose it is in the first row and the first column, hence A11 is equal to 1. Similarly, Aij 31, 3 means the third row and the first element, which is 7. I can also read the fourth row in the third column over here is minus 2. So if I want, I can write down A43 is equal to minus 2. And so on you can write for all the elements. So this is how a matrix and an element in it is represented. Next, let's talk about some types of matrices. First one is called as a row matrix. A row matrix means there is only one row. Like you can see A, B, C. These are the 3 elements. There is only one row. Or I can take 1, 4, 9. This is another example. Next is column matrix. A matrix which has only one column is called as a column matrix. Like you can see here A, B, C. These are the 3 elements held in a column, single column. So it is called as a column matrix. Here also you can see there is 3 elements. Now I'll just write down something for you. This is a row matrix. As you can observe, there is only one row, correct? So number of columns is going to be 3. So 1 by 3 is the order of matrix. Same way here also I've written 1 by 3. If you want, you can write a 1 by 2 also. Say it is 1 and 2. This is 1 row, 2 column. So this is also called as a row matrix. Column matrix means the column number should be 1 and there can be n number of rows. So here if you see, there are 3 rows and there is only one column. Same way here, 3 rows, 1 column. You can have 1, 2. This is going to be 2 rows, 1 and 2, and there is only one column. So it is 2 by 1. So this is how a row and column matrix is represented. Next, let's talk about square matrix. It is a matrix where number of rows and columns are equal. You can see here order is 3 by 3, 3 by 3, 2 by 2, 1 by 1. This matrix with only one element, that too the value is 0, this is called as a null matrix or a zero matrix because the value is 0. So this is all about square matrix. Next, square matrix can also be written in various other forms. Now look here, square matrix A is called as a symmetric matrix if Aij is equal to Aji for every I and j. Now look carefully. A, D and F, these are the 3 diagonal elements. You can see this is forming a diagonal over here for the matrix. If you observe this and this element, the value is same. Now let's observe the position. I'll just mark the row number this is 1, 2, 3. Column number is 1, 2 and 3. So when I have 3 rows, 3 columns, if I observe this element B, I can see its position is first row, second column. So I can say it is A1, 2. Similarly, this B is in second row, first column. So it is A2, 1 and the value is B. Similarly, A1, 3 and A3, 1 have the same value. A3, 2 and 2, 3 have the same value. So you can see B, C and E. These are forming elements such that they are symmetric above and below the diagonal. So this kind of a matrix will be called as a symmetric matrix, and obviously it has to be a square matrix. So this is that matrix A. So just label it A. Next comes square matrix with all non-diagonal elements as 0 is called as diagonal matrix. Now if you observe the matrix that I have written here, A, B, C are the diagonal elements. All the other elements are 0. So this type of matrix or this type of a square matrix, which is 3 by 3 order, will be called as a diagonal matrix. Also you can have something like this, A, B and these term is 0. So this is a 2 by 2 diagonal matrix. So we can have 2 by 2, 3 by 3 and likewise more of them. Now suppose if a diagonal matrix with all the diagonal elements is 1, this will be known as a unit matrix. If you observe here, all the diagonal elements are 1 and rest of the elements over here that you see are 0. So this type of a special diagonal matrix is called as a unit matrix. Now this is a 3 by 3 type. This is a 2 by 2 type. You can also have a 1 by 1 diagonal matrix, which is very important because it is written that diagonal matrix has diagonal element as 1. So this is a diagonal element. Rest elements are 0, but here there is only one element. If you want to write a 4 by 4 matrix, it will be something like this: 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So here is a 4 by 4 diagonal matrix, and likewise you can continue writing for n number of diagonal matrices. Next, let's talk about a square matrix which has all the elements below the leading diagonal are 0 as 0. It is called as upper triangular matrix. Now observe, A, D and F are the diagonal elements. You can observe there is a small triangle which I can form with the elements below the diagonal. When you have all these elements as 0, it will be called as upper triangular matrix. Now similarly, if you have a square matrix wherein above the diagonal you can form a square like this with the zeros, this will be called as a lower triangular matrix. So these are all the types of matrices which we need to know. Next, we'll start with some matrix operations. This is very important as far as FEA subject is concerned because you're going to use a lot of addition, multiplication, subtraction throughout your FEA subject. So let's start with the basic of equality of matrices. Now two matrices can be called equal when the order of the two matrices are same. So let me write A is going to be a 2 by 2 matrix, and let's say B, which is also going to be a 2 by 2 matrix. Okay, so I will say that these two matrices are equal. So first condition is the order will be same. Second is each element of one matrix is equal to the corresponding element of the second matrix, which means if A is 1, 2, 3, 4, B also has to be 1, 2, 3, 4. Now I should have the corresponding, means the position. First column, second column, first row, second row. You can observe first row, first column, element is 1. Again first row, first column, element is 1. Which means they all should be equal in both the matrices. So this is just a basic rule of equality of matrices. Next we have matrix addition or subtraction. You can add two matrices A and B only if they are of the same order. Like I just wrote 2 by 2, 2 by 2. So this order has to be same. The elements need not be equal in both of them, but they have to be of the same order. Only then you can add or subtract two matrices. I think you have already studied this in mathematics, so I'm not taking up more examples on this. We'll just shift to multiplication of a matrix by a scalar. This is done by multiplying each element of the matrix by the scalar. You can observe k is a scalar value. This value of k can be anything. It can be 1, it can be 2, it can be 1 by 2, it can be 1 by 3, it can be any other number. So what you do is, if this is a common number which is outside, you just have to multiply with each element and write the final answer. So this is how multiplication of a matrix is done by a scalar. If you are aware of the fact only multiplication in matrices is possible, division is not possible. So what you can do is, you can actually multiply with a scalar like this, and that is how you divide each term by a particular common number, as division of matrices is not possible. Next, we will definitely talk about multiplication of two matrices. Two matrices P and Q can be multiplied only when number of columns of P is equal to the number of rows of Q. Now observe here, P and Q are the two matrices that I have written. This is the order of the entire matrix and this is the order of the second matrix. If you observe, the number of columns of P should be equal to the number of rows of Q. Only then you can multiply these two matrices. Now how am I supposed to multiply them? P is multiplied by Q. So I'll just write down the matrix. Now observe, the resultant matrix which I'll obtain, so I'll call it as R, which I obtain, will be of order. If you see 4 and 4 are equal, so I have multiplied. Whatever number is pending, 3 by 2, 3 indicates the number of rows of P. So I'll have 3 as the number of rows of the resultant matrix and 2 is the number of column for Q. So this number will be taken up by the resultant matrix. Whatever remains, just write it for the resultant matrix. And now I'll show you how do I multiply. So R3 2 will be. Now look, how do I multiply? I'll have 3 rows. So 1, 2, 3. I have 2 columns, 1 and 2. My order is 3 by 2. This is something that I write here. Now how do I multiply? I'll multiply 1 into 1. Then I'll multiply 2 into 2, 3 into 3 and 5 into 4 and add all these values that I get. So the first value over here will be 1 into 1 plus 2 into 2 plus 3 into 3 plus 5 into 4. So this becomes my first element or the first row. This is my first row, first column value. For the second one, okay, let's write it here. For the second one, I am going to multiply 1 into 5 plus 2 into 6 plus 3 into 7 plus 8 into 5. Now if you add them and you multiply, you will get the value as 5 plus 12 plus 21 plus 40. Next I am going to multiply for the second row and first column. So 6 into 1 is 6 plus 7 into 2 is 14, 4 into 3 is 12 and 8 fours are 32. Next for this column I am going to write 6 into 5 is 30, 7 into 6 42, 4 into 7 28 plus 8 into 8 64. Likewise 9 plus 0 minus 3 plus 4 and I have 45 plus 0 minus 7 plus 8. These are the values that I get. Now when I sum it up, I get the matrix as, so this is the value of the resultant matrix R 3 by 2 that I obtained by adding and placing these values. So this will be a 3 by 2 matrix that you can observe. So this is how a simple multiplication of two matrices is done. Next, let's talk about some related terms with matrices. First one is transpose of a matrix. The matrix formed by interchanging the rows and columns of the matrix is known as a transpose of matrix. Let's observe. A has element 1, 2, 3, 4, 5, 6. It has 2 rows and 3 columns. When I write the row as a column, if you observe here, 1, 2, 3 becomes a column, 4, 5, 6 becomes another column. This matrix which is formed now will be called as transpose of matrix A. It is denoted by A dash or A raised to T. This T stands for transpose, so A transpose. This is how it is written. You can observe the order was 2 by 3. It has now become 3 by 2. Next is adjoint of a square matrix. Adjoint of a square matrix is a transpose of the matrix formed by the cofactors of the elements in the determinant of the matrix. Now this is a matrix A which is given to me. This is of order 3 by 3. I'll have to first find a matrix which is formed by the cofactors of the elements in this matrix A. So let's start. So therefore, I'll have determinant of the matrix which I have to find. For finding this, I'll have to do a very simple calculation, which is, suppose if I am calculating the cofactor for the first element 1. For that, first I'll have to forget the row and the column in which it is present. So suppose if it is present in the first row, first column, forget it for some time. Now you can observe there are 4 more elements that you can see. Just simply multiply 5 into 0 minus 6 into 8. So you will get 5 into 0 minus 6 into 8, which is equal to minus 48. So this is the cofactor of the first element which I am going to write over here. Next, suppose if I have to calculate for 2, I'll forget the second row and the first column. It is the place where it is existing. So if you forget these two, what remains is 4 into 0 minus 6 into 7. So I get 4 into 0 minus 6 into 7. So I get the value as minus 42. So this is the cofactor for the second term. Likewise, you can calculate for all the other terms. Now here I would like to add one thing, that since we are calculating the determinant of this matrix as you have seen over here, so this is called as determinant of this matrix, as you can observe. Now this matrix which I am forming over here, this is called as a cofactor. This entire matrix will be cofactors of each element. Now apart from writing these values over here, you also have to multiply with minus 1 raised to the summation of the row and the column in which it is present. For example, if it is in the first row, first column, it will be minus 1 raised to 1 plus 1. 1 plus 1 is 2. So minus 1 square will be 1. So I leave it as minus. Next term for the second one over here will be minus 1 raised to 1 plus 2. So minus 1 raised to 3 is minus 1. So here another minus sign will be added. So this becomes plus. When you see this term, it is minus 1 raised to 1 plus 3, 4. So again this will be 1. Minus 1 raised to 4 is 1. So multiply, it will still remain the same. Next over here, it is 2 plus 1, 3. So minus 1 raised to 3 will be minus 1. So this is another term. Now likewise I'll calculate for all of them. So these are the values that I obtained. Now again I'll solve for this element. Here it is minus 1 raised to 4, so it is positive. Here it will be minus 1 raised to 5, so negative. So I'll just change the sign here. Now I'll just give you a small hint if you don't want to go around doing this completely. These are the 4 places. If you see, there's a kite which I can form. This and these. These are the 4 corners. This is a kite which I have drawn where you need to change the sign. I would explain you why. Because these are the 4 positions where minus 1 raised to this m plus n is going to become odd. So when I have an odd number here, minus 1 raised to odd number is always minus 1. And minus 1 raised to even will always be plus 1. So these are the 4 places where I'm always going to get a minus 1 raised to odd. So you can just remember as a trick also that after finding all the values by closing the position of the element, by closing the row and the column of the element position, what you can do is you can calculate the values, then just change the sign for these 4 elements. So this is just a trick for remembering as to which element's sign has to be changed. Now I have formed a matrix which is formed by the cofactor of each element. So this is how it is calculated. Next I am going to write down directly the adjoint of matrix A. Now the adjoint of this matrix A can be written from here by simply finding out the transpose of this matrix. For that I am going to convert the row to column and the column into row. So this minus 48, 42 will come as a column value and minus 3 will be placed here. Next 24 shifts here, 21 is here and 3 at this position. And last I have minus 3, 6, minus 3. So this is the adjoint of this matrix A which I have found. Last I want to talk about an operation which is called as inverse of a matrix. If A is any square matrix, then its inverse is denoted by A inverse. and A into A inverse is equal to I. So this is one formula which you need to remember. This A inverse can also be given by another formula, that is adjoint of A upon mod of A. You just saw I calculated adjoint of A. You know how to calculate mod of A. Mod of A is nothing but the determinant value. So determinant calculation can be directly done on the calculator for a 3 by 3 matrix. If it is more, you need to manually solve it. So just by calculating determinant of a matrix and the adjoint value, if you divide both of them, now when I say divide, it doesn't mean that I actually divide here. It means it is multiplied with a scalar value. If you understand, I have multiplied this 1 upon A into adjoint of A. So with this, I end this session. In the next session, we will discuss about another technique for calculating the inverse of a matrix. In case the matrix becomes more than 3 by 3, it becomes very difficult to solve by these formulas. So I'll show you another method which is called as Gauss elimination method. I hope you have understood the lecture. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you. Hello everyone, welcome to the next session of finite element analysis. In this session, we will be talking about Gauss elimination method. This method involves converting the given matrix into a unit matrix by making suitable row or column operations. Now I am going to use row operations. You can also use column operations. Now here you are also going to multiply another unit matrix. So whatever operations you will do on the given matrix, you also need to do it on the unit matrix. This matrix will get converted ultimately into a unit matrix, and the unit matrix that you write on the other side will get finally converted into another type of matrix, which will be exactly the inverse of the given matrix. So I have a numerical over here to explain you the method. Find the inverse of the matrix by Gauss elimination method. So this is the matrix which is given to me. This is of order 4 by 4. So what I am going to do is, for solving, I will first copy the matrix which is given to me. It is 2, 1, 0, 3, minus 1, 0, 4, 1, 2, 1, 3, 7, 1, 4, 2, 1. Since it is 4 by 4, I am going to multiply a unit matrix of the same order, which means it should be a 4 by 4. So 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0 and 0, 0, 0, 1. So this will be my unit matrix. Now I am going to convert this matrix into this form, and the unit matrix which I have written will ultimately get converted into a different matrix altogether with different elements, and that will be the inverse of this matrix. Now I will start by first using a row transformation wherein I'm going to convert this 2 into 1, because you can observe unit matrix has the first element as 1. Now there is a trick for solving this numerical, that is, you should first focus on this first element, convert it into 1, make all the elements below it as 0, then go to the second element over here, make it as 1, correspondingly make these elements as 0 by obviously using this element which you have formed. Then make this 3, position of this 3, this position should be made 1, these elements 0, and finally this element should be made 1 and these element as 0. So this is how I should be converting the given matrix into a unit matrix, and the unit matrix will ultimately undergo the same operations which this matrix is undergoing, and it will form a different matrix altogether. So let's start. I will first start with this element. Now for converting this element into 1, the number 1, I will be just simply R1 plus R2. If I just add this R2 into this R1, I get 2 minus 1, 1. So I can easily make this number as 1. So I will write R1 dash, because this initially is R1, this is R2, this is R3 and this is R4. So I am making this R1, this row I am completely changing into some other values. Hence I am writing R1 dash is equal to R1 plus R2, which means this new row will be formed by adding this row plus these values over here. So I will get the first value as 2 minus 1, 1, 1 plus 0 is 1, 0 plus 4 is 4, 3 plus 1, 4. Rest of the elements I will write as it is. Just make sure that when you are converting a particular element into 1, the number 1, do not do any other operations along with it. Just leave it with one operation. Next, I am going to solve for this first row. It will undergo the same operation like this. So this will be R1 plus R2. So 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. And 0 plus 0 is 0. Rest of the elements I'll simply copy down. So 0, 1, 0, 0. 0, 0, 1, 0. 0, 0, 0, 1. Next, I will work on these three elements and I'll try to make them as 0 by making use of this number. So can I say R2 dash is equal to R2 plus R1. Suppose if I add R1 value to this number, I get 0. Next, I'll solve for R3 dash. This number will be R3 minus 2 times R1. Please observe, it is 2 minus 2 because of this operation. It becomes 0. And lastly, R4 dash, this number will be R4 minus R1 because it is 1 minus 1, 0. So I get the result as first row will remain the same, 1, 1, 4, 4. Second row will become R2 plus R1. So here I am going to add these first values. So the first number is 0. Next I have this matrix. I will simultaneously write for this one as well, 1, 1, 0, 0. So this becomes 1, 2, 0, 0. Next I will write for this value, R3 dash. So it will be R3 minus twice R1. First value is 0. 1 minus 2 is minus 1. 3 minus 8 is minus 5. 7 minus 8 is minus 1. Next I have 0 minus 2. So minus 2. 0 minus 2 minus 2. 1 minus 0 is 1. And this is simply 0. Next I'll solve for the fourth row. It is R4 minus R1. So from this value I have to subtract the R1 value. 1 minus 1 is 0. 4 minus 1 is 3. 2 minus 4 is minus 2. 1 minus 4 is minus 3. Here I have 0 minus 1. Next I have minus 1, 0 and 1. So this is how I have converted the first column. If you observe, I am using row transformation, but I am going to change my columns. This is row transformation method. So I have converted first element and the consecutive 3 numbers in the first column. Now I am going to work on this element. Now in this question, this element is 1, but not necessarily in every question you will have this value as 1. So you may also have to convert this value. Now since here I don't have to do it, I leave the operation wherein I need to convert this value as 1. So I'll directly work towards making this first, third and fourth element as 0. I'll have R1 double dash because R1 dash is already done. So can I write R1 double dash will be R1 minus R2. Now here also I need to use dash because I've just written R1 dash R2 dash. So these are R1 dash and R2 dash, R3 dash, R4 dash. So just make sure that you're writing them properly. Next I'll have to convert this one. So this will be R3 double dash is equal to R3 dash plus R1 dash. I'll be using R2 dash. Then I'll have R4 double dash is equal to R4 dash minus 3 times R2 dash. Everything should be in reference to the new found element in the new row. So R2 dash is actually my new row which I'm using. So this is the values which I have found. Now let's make the matrix. R2 will remain same. So I can just write down 0, 1, 8, 5. And here I'll have 1, 2, 0, 0. So just writing these elements as the same. Now I'll fill up R1 double dash. So R1 double dash will be R1 dash minus R2 dash. So I have this value minus this value. So you will observe that this column will not change as 1, 0, 0, 0. This will remain same. Now look at the operations. 1 minus 0 is what I am doing. It will still remain 1. This is 1 minus 1, 0. This will be 4 minus 8 minus 4 and 4 minus 5 minus 1. Next 1 minus 1, 0. 1 minus 2 minus 1, 0 minus 0 and 0 minus 0. So this is how I get the first row. Next I'll go towards the third row. This is R3 dash plus R2 dash. So I'm adding this 0 plus 0 over here. Minus 1 and 1. This becomes 0. Minus 5, 8. This becomes 3. Minus 1, 5 becomes 4. Here minus 2, 1 becomes minus 1. Minus 2 and 2 is 0. 1, 0. R4 double dash. This new row will be R4 dash minus 3 times R2 dash. Observe it is still 0 because we are doing in reference to R2 and our R2 value is 0. So no changes will happen in this column which I have already found. This will be R3 minus thrice R2 dash. So this will be 3 minus 3, 0. This value minus 3 times this value. This is A3s are 24, minus 24 and 2 is minus 26. This will be minus 15, minus 3, minus 18. Minus 3, minus 1, minus 4, minus 6, minus 1, minus 7. This is 0, so this will remain the same. This is 0, so this will remain the same. So this is how easily you can convert it. Now I will work towards converting this element as 1. Observe carefully. I need to divide this element with 3 so that this element becomes 1. So I'll write down R3 triple dash will be R3 double dash divide by 3, which means I am multiplying this row with a scalar 1 by 3. So when I divide all these elements by 3, observe what do I get. First row will be 1, 0, minus 4, minus 1. It will remain same. 0, 1, 8, 5 will remain same. 0 divided by 3 is 0. 0 divided by 3 is 0. 3 divided by 3 is 1. And this will be 4 by 3. The last row will again remain same. 0, 0, minus 26, minus 18. Here also first row, second row and fourth row will remain the same. So 0, minus 1, 0, 0, 1, minus, okay, it's 2, 0, 0. This will be minus 1 by 3, 0, 1 by 3, 0. And finally it will be 4, minus 7, 0, 1. So just copied the rows from above. Next, I will work towards converting these elements as 0. So I will have R1 triple dash will be R1, this is double dash, plus 4 times R3 triple dash. Next, I'll work towards this, which will be R2 double dash will be R2 dash, this one, minus 8 times R3 triple dash, and last R4 triple dash will be R4 double dash plus 26 times R3 triple dash. So let's calculate now. I'll just add 4 times R3 double dash to this value, which is still going to be 1. Now if you want, you can just write these values 0, 0, 0, 0, 1, 0, 0, and you really need not calculate for them, including this one, because I am very sure that I have not made a mistake so that these values will change. I am going by my procedure, and I am also taking reference of the numbers such that in these columns here the value is 0. So even if you do an operation here, the other numbers are not going to change. So I can confidently write this much portion of the matrix, which means I am actually saving on some time. So I am calculating for the first row. So this will become 0 because I have made this calculation. And this value I need to calculate, this will be this value plus 4 times this value. So now I'll just go for these operations and I'll calculate. I think by now you have understood. So I'll just show you the values that I obtained. So this is the result that I obtained. Next, I am going to convert this number into 1. So for this, I'll have R4 4 dashes will be R4 triple dash into 3 by 50. When I multiply this with 3 by 50, I'll get 1. So my answer becomes, so this is the matrix that I obtained by this operation. Next, I am going to convert these values as 0. So my operation will be R1 4 dash will be R1 triple dash. I have to operate with respect to this value which I have just found. So it will be minus 13 by 3 into R4 4 dash. Next I'll calculate for R2 4 dash will be, okay, this will be 3 dash because there is one operation less for R2. So R2 3 dash will be R2 double dash plus 17 by 3 of R4 4 dash, and finally R3 4 dash will be R3 triple dash minus 4 by 3 into R4 4 dash. So when I simply subtract, I am going to get these values as 0. Now I'll just calculate these values. So these are the values that I get at the end. Now this matrix that I have obtained is actually the inverse of the original matrix A which was given to me. So I can simply write down that the inverse of matrix A is this matrix which I have just obtained. Now I'll just convert them into decimal values. So I get 1.96 minus 0.64. This is how the inverse of a matrix is supposed to be found by Gauss elimination method. I hope you have understood the lecture. If you have any doubts or you want me to solve any numerical, please write to me in the comment section. See you in the next session. Thank you.